Hi, everybody. Hope you're doing well. I wanted to let you know what we did in science class today, which is Wednesday, November 3rd. So we had reviewed this stopper crash data that we had collected when we did those little scenarios on the number cards. I had posted that on Friday. Um, so first of all, we made sure everybody filled these in, and just a reminder, there's really two sides of this page, and the left-hand side of this page over here showed that we were keeping the same speed. So this whole section in here was the same speed of 11 meters per second, and everything in this section was the 22 meters per second, and everything over here is 44 meters per second. But what we were changing each time was the mass of the car. So 1 stands for the sports car, 3 is like 3 times that amount, which was the SUV, and 37 was 37 times the mass, which was like the semi-trailer. Okay, so that shows you the speed staying the same, but then what happens when you have different mass. Okay, on the other hand, we had uh, the same mass. So this entire section here is the sports car, but what we changed within that was the speed. And then down here, same thing. This whole section is the SUV, but we changed the speed. Okay, so we looked at all this data and tried to find some trends, and you can see every single time when you increase the mass, the kinetic energy goes up, right? That happens in this section too. That happens in this section. Didn't matter what the speed was when you had the mass larger, you saw an increase in kinetic energy. And on the other side, the same thing was true about speed. So when the mass stayed the same, so as the sports car, but the speed increased, the kinetic energy also increased. So then the question we were trying to determine really was what affects kinetic energy more? If I want to have something that has this huge collision that has a lot of transfer of kinetic energy, do I want to increase the speed? Is that what's going to make the most kinetic energy? Or do I want to increase the mass? So what we did was we worked through these different questions. And the first 4 questions really deal with mass and how mass affects kinetic energy. And when we did that, we were still looking back at all this data. So the first 4 questions dealing with mass, first of all, as the mass increases, kinetic energy also increases. You could say the opposite. You could say as mass decreases, kinetic energy also decreases. But then the question was, well, how much does it actually make it increase? So how does kinetic energy, how much does it depend on mass? So we looked at specific scenarios. If mass triples, and the example was like when you go from a sports car, which had the mass of 1, to an SUV, which was triple the mass, what happened to the kinetic energy? Well, we looked at that in these terms. So going from this 1 in mass to this 3 in mass, we were multiplying by 3. We tripled it. And if you look at the kinetic energy associated with those, to go from 225 to 675 is exactly triple the amount. So when I tripled the mass, the kinetic energy tripled. We looked at that when we multiplied the mass by 37. In other words, to go from the sports car to the semi-trailer, we had to multiply by 37. Well, guess what? 225 times 37 will get you 8,325. So that shows however much I multiply the mass, the kinetic energy is going to multiply that same amount. So there's a couple other scenarios in here, and you can think through what these 4 questions would be, but that's the main point. If I multiplied the mass by 7, I'm going to be multiplying my kinetic energy by 7. If I multiply my mass by 113, I'm going to be multiplying the kinetic energy by 113. Okay, so that shows us how mass affects kinetic energy. The bottom set of questions talks about speed. So as the speed increases, kinetic energy increases, or uh, when speed decreases, the kinetic energy decreases. That's really talking about all this stuff on the right-hand side. And so you can see the faster that we got, the more kinetic energy there was. The faster we got, the more kinetic energy. Okay, so again, the question was, how much does it affect it? Does it affect it as much as mass did? More than that? So we did those same types of comparisons where we said if speed doubled, so if example going from 11 meters per second, which we looked at, to 22, that's multiplying by 2, right? That's doubling the speed. How did that affect the kinetic energy? So here's the type of example. Speed goes from 11 to 22, so that's multiplying by 2. Kinetic energy goes from 225 to 900. That's multiplying it by 4. Okay, so it's not just keeping that um, same rate. It's not just keeping that same factor of 2, but it's taking 2 times 2, which is multiplying it by 4. And that same thing happens when we look at what if we quadruple the speed, like going from 11 to 44, right? To get from 11 to 44, we're multiplying by 4. On this side, the kinetic energy didn't just get multiplied by 4. 225 times 4 doesn't get you down to 33,600. You need to multiply it by 16. So over here, we went times 4. Over here, we multiplied by 16. So the pattern that we were hoping you would see was that when you increase the speed by whatever factor it is, the kinetic energy gets increased by that factor squared. So that's a much larger amount. So ultimately, when we took all these different questions, and I'd still suggest you look through those and just double check that you understand that, we found that speed has a bigger impact on increase in kinetic energy than mass does. Both of those things, if you increase mass or if you increase speed, both of them will cause the kinetic energy to be higher, but speed is a bigger factor. Okay? You can get more kinetic energy more quickly by speeding it up rather than by simply adding more mass. Okay, so that was the general idea of what we did in class today. And then as kind of a reinforcement of all of that, there's an assignment of reading an article. That article is found on page 41 through 44. And so read that, and I've got the worksheet that goes along with it linked, so you can print that out and fill that out as you go. And that should reinforce some of the things that we've talked about here in class today. Have a great day.